Hey guys, Mr. Backward here. In this video, we're going to focus on solving a system of linear equations using elimination. So when we're using elimination, there are a few steps that we're going to follow. Step number 1 says that we want to get the equations so that they have opposite numbers in front of one of the variables. So for example, if we had an equation with a 2 in front of the x, then we would want to have a negative 2 in front of the x in the other equation. So opposite numbers in front of one of the variables. Then what we're going to do is we're going to take those two equations and we're going to add them together. And then once we add them together, we're going to go through and solve. And that's going to give us the answer for one of our variables. But then what we need to do is take that answer from step number 2 and substitute that back into one of our equations so that we can go through and solve to figure out what our other variable answer is. So we're going to take a look at this example here. The top equation says 2x plus 3y equals 11, and the bottom equation says negative 2x plus 5y equals 13. Step number 1 said that we wanted to have opposite numbers in front of one of our variables. And it doesn't matter which variable we're working with. So in this case, as we look at the x's, I see a 2x in front of that equation on top, and I see a negative 2x in front of that equation on bottom. So those x variables have opposite numbers in front of them. So step number 1 is taken care of. Step number 2 says that we want to go through and add these equations together. So if we take 2x and we add negative 2x, because of those opposite numbers, when we add those together, that's just going to cancel out. Now when we take 3y and add 5y, that's going to give us 8y. And when we take 11 and add 13, that's going to give us 24. Now we should be able to go through and solve this to figure out what our y value answer is. We've got that 8 in front of the y, and remember 8y really means 8 times y. So to get rid of the 8, we're going to have to divide everything in here by 8. So we're going to get y equals 3. Now remember, when we're solving a system of equations, our answer is always an ordered pair. And we just figured out that the y value was 3. But we still need to go through and figure out what the x value is. So step number 3 says take the answer that you just got for that first variable, and we're going to pick one of the equations, and it doesn't matter which one we use. I'm just going to use the top one, but we're going to take that first answer that we got and plug it in for that y value. So then we would get 2x plus 3 times 3 equals 11. Well, 3 times 3 is 9, so we get 2x plus 9 equals 11. We want to solve this to figure out what our x value answer is. So I'm looking at this plus 9, and to get rid of plus 9, we're going to have to subtract 9 on both sides of our equation. So that's going to give us 2x equals 2. We still need to get rid of the 2 that's in front of the x, so we're going to divide both sides of our equation by 2, and that's going to leave us with an x value of 1. So then, for our answer, we know that the x value in this ordered pair is 1. So the final answer for this system of equations is the point 1, 3. As we take a look at our next example, we've got 4x minus 3y equals 5, and our other equation says negative 2x plus 3y equals negative 7. So step number 1 says that we want to get a variable so that we have opposite numbers in front of that variable. So if we look at the x's, we've got 4x and negative 2x. Those are not the opposite numbers. But if we look at the y's, we've got negative 3y and positive 3y. Those are opposites of each other. So step number 1 is taken care of. Step number 2 says that we want to go ahead and add these equations together. So 4x plus negative 2x, well, 4 plus negative 2 is positive 2x. And if we look at negative 3y plus 3y, because those are opposites, when we add those together, they're going to cancel each other out. And then on the right-hand side of our equal sign, 5 plus negative 7 is going to give me negative 2. So we have the equation 2x equals negative 2. Now we want to get x alone. So I see this 2 in front of the x, and that means 2 times x. So in order to get rid of multiplication, we're going to have to divide everything in here by 2. And when we do that, we should get x equals negative 1. Now remember, the answer for a system is always an ordered pair. We just got an x value of -1, but we still need to figure out what our y value is. So we're going to take this answer that we just got, and we're going to go back to one of our equations, and it does not matter which one we choose, but we're going to take that x value and we're going to plug it back in. Let's use the top equation, and we're going to plug in the -1 for the x value, since that's what x is equal to. So we would have 4 times -1 minus 3y equals 5. Well, 4 times -1 is -4. Then we have our minus 3y, and this is equal to 5. We're going to solve to get y alone. I'm looking at that minus 4 out in the front. To get rid of minus 4, we're going to have to add 4 on both sides of our equation. So that's going to leave us with -3y equals 9. We want to get rid of the -3 that's in front of the y. Be careful though, a lot of times when people see a negative number attached to a variable, they want to add it over to the other side, but we have to remember that having a number attached to a variable means that there's multiplication happening, so we do need to divide by the -3. And when we do that, we should get a y value of, well, 9 divided by -3 is going to give us -3 as an answer. So as far as our ordered pair goes for the solution, the y value we just said was -3. So the final answer for this system of equations is the point -1, -3. Now as we take a look at this example, for the top equation we've got -9x plus 21y equals -48. And for our second equation we've got -9x plus 5y equals 16. Step number 1 said that we wanted to have opposite numbers in front of one of the variables. And if we look at what we've got right now, neither one of these variables has opposite numbers in front of it. If we look at the x's, those have the exact same number in front of it, but we don't want the same number, we want opposite numbers. So in a case like this, one thing that we're allowed to do is we can change all of the signs in one of our equations. So, for example, if we wanted to work with this second equation here, we could change all of the signs in front of those numbers. So I could change this -9x to a positive 9x. I could turn this plus 5y. Well, if I change the sign there, that's going to turn into a minus 5y. And on the right-hand side, if I change the sign in front of a 16, that's going to turn into a -16. So I'm going to cross off that equation because we've changed the signs, and we've changed it into this new equation. Now, we haven't changed anything on the top equation, and I'm not going to because we want to have opposite numbers in front of one of the variables. I just got an x with a positive 9 in front of it, so I want to keep this -9x the same. So I'm just going to copy down that top equation just as it's written so that we can do our adding with these equations. Now when we add these equations together, because of the positive 9x and the negative 9x, when we add those together, these x's are going to cancel out. When we add the negative 5y to the positive 21y, well, -5 plus 21 should give us 16y. And on the right-hand side, when we take -16 plus -48, that's going to give me -64. Now, we do want to work on getting y alone. Having 16y really means 16 times y. So in here, we want to divide everything by that 16 in order to cancel that out. So we should get y equals -4. Remember, we're building an ordered pair for our answer, and we just said that the y value was -4, but we still need to go through and figure out what the x value is. So we're going to go back up to the top, and we're going to pick one of the equations to work with. It doesn't matter which one you choose. Because I see a big number, a 21, in front of that y on top, I'm thinking I don't want to use that one. So I'm going to choose to use the second equation this time. And what we're going to do is fill in that -4 that we just got for that y value. So we're going to have -9x plus 5. we're filling in the -4 for the y value, so times -4, and this equals 16. Now doing the multiplying in here, 5 times -4, we're going to end up getting -9x. 5 times -4 is -20 equals 16. We want to solve for x, so to get rid of that -20, we're going to have to add 20 on both sides of our equation to get that to cancel out. So we're going to have -9x equals 36. Having that -9 attached to the x means -9 times x. So to get rid of that multiplication, we're going to have to divide everything in here by -9. And that's going to leave us with an x value of -4. So I'm going to go back up to my ordered pair. My x value is -4. So the final answer for this system of equations is the point -4, -4. In our next example, we've got the equations 8x minus 4y equals -4 and 4y equals 3x plus 14. If we think about all of the examples that we've done up to this point, we've always had kind of the like terms lined up. So I'm going to run through those last examples quick just so we can see what we're talking about. In this first example, we had the x's lined up, the y's lined up, and the numbers lined up. In the next example, x's were lined up, y's were lined up, numbers were lined up. In the next example, x's were lined up, y's were lined up, numbers were lined up. But as we look at this example, that's not the case. So sometimes we need to do a little bit of rearranging to get our like things lined up. So the first thing I want to do is I'm looking at this 3x, which is on the right-hand side of that second equation, and I want to move that over to the left-hand side. So we're going to have to subtract 3x on both sides. So that's going to give me the equation -3x plus 4y equals 14. Now with this top equation, I'm not changing anything there. I'm just going to copy it down as it's written. So 8x minus 4y equals -4. So now we've got the x's lined up, the y's lined up, and the numbers lined up. And as we look at the variables, the x's don't have opposite numbers in front of them, but the y's do. So we're going to add these equations together. And when we do that, the 4y and the -4y will cancel each other out. -3x plus 8x is going to give me 5x. And on the right-hand side, when we take 14 and add -4, that's going to give me 10. I do want to get x alone in here, and right now I have that 5 in front of the x. So I'm going to divide everything in here by 5. So that should leave me with an x value of 2. Now remember, we're building an ordered pair for our answer. The x value is 2, but we still need to figure out what our y value is. So we're going to pick one of the equations to work with. Doesn't matter which one, but we're going to plug in that 2 for the x value. So I'm going to use the top equation, and I'm going to go 8, fill in the 2 for the x, minus 4y equals -4. Well, 8 times 2 is 16, minus 4y equals -4. This is a positive 16, so to move that over to the other side, we're going to have to subtract 16 from both sides. So that's going to leave me with -4y equals -20. I want to get rid of the -4 that's attached to the y, so I'm going to divide everything in here by -4, and that should leave me with a y value answer of 5. So I fill that in for the y value in my ordered pair, and I get the 0.25 as the answer to this system of equations. One more example to look at in here, and what I want you to notice about this one is that, again, we don't have things being lined up. Here we have x's being lined up with y's, and here we have x's being lined up with y's, but we want to have x's lined up together and y's lined up together. So what I'm going to do is I'm going to leave the top equation the same, so I'm going to leave that as 2x plus 5y equals 12, but I'm going to flip-flop the x's and the y's in this second equation. Now when you move this minus 4x to the front, we do have to keep the negative on it. So it is a -4x. This is a positive 5y, so this becomes plus 5y equals 6. Now notice we want opposite numbers in front of one of the variables. We don't have opposite numbers in front of the x's. We have the same number in front of the y's, so this is a case where I'm going to change all of the signs in front of one of these equations. And again, I'm going to leave that top equation the same. I'm going to leave that one as 2x plus 5y equals 12, but I'm going to change all of the signs in front of the numbers on that second equation. So the negative 4x is going to turn into a positive 4x. The plus 5y is going to turn into a negative 5y. And the positive 6 is going to turn into a negative 6. So now when I add these equations together, because the y's have opposite numbers in front of them, those y's are going to cancel out. 2x plus 4x is 6x, and 12 plus negative 6 is 6. We want to get x alone, so I'm going to divide everything in here by 6. So that should leave me with an x value of 1. So if I build my ordered pair for my answer, the x value is 1, but we still need to find the y value. We're going to pick one of these equations to work with in order to solve for y. Let's just use the top one. We're going to fill in the 1 for the x value. So I'm going to go 2 times 1 plus 5y equals 12. 2 times 1 is 2, so we get 2 plus 5y equals 12. With this 2 to move it over to the other side, because it's a positive 2, we're going to have to subtract 2 on both sides. So I get 5y equals 10. To get rid of the 5 in front of the y, we're going to have to divide everything in here by 5. So that should leave me with a y value answer of 2. So the final answer for this system of equations is the ordered pair 1, 2. That's going to be it for this video. Thanks for watching.